Hey there, everyone. Today we're looking at our very first lesson of Unit 4, which is on systems of equations. So we're going to be specifically looking at the graphs of systems of equations in this lesson. Our learning target is that we can write a system of equations from a graph. Those are the most important things. And a lot of these things you probably already know from previous lessons because we have learned how to write an equation from one line. So it's not that much more difficult to write two equations from two lines. For instance, we already know how to identify slopes and y-intercepts from graphs. With a slope, remember we do rise over run, and the y-intercept is where the graph touches the y-axis. I can also write an equation in slope-intercept form, but now the only difference is that we are now doing it from both graphs, two lines instead of one line. And we have also already learned how to convert from slope-intercept form to standard form. The only thing that's really new for us in this lesson is that we can identify the solution to the system of equations. It does have an answer, a solution, and we're going to talk about what that solution is in a moment. So let's go and look at the first example in your notes. And it's asking us to write the system of equations from this graph. So first, let's start out by writing the equation of graph number 1. And so I'm gonna do them in the color that we see them on there. This one's going to be equation number 1. And then the one that's in green will be equation number 2. Okay. So green is number 2. I highly encourage highlighting in different colors. That could be really useful on something like this when we have two lines. Okay. So the equation for the first one, first let's find our y-intercept. It is at 6. So that's the b value. And then we need 2 points in order to find our slope. So I need another point. Here's a good one. And then we find our rise and our run. So it's rising 1, 2, 3, 4, 5, and running 3. So let's write our equation. Y equals mx plus b, right? I'll write that at the top. Y equals mx plus b. Remember, m is our slope, rise over run. So we're rising 5, running 3. From left to right, our graph is increasing, going up and to the right. So it is a positive slope. And then where did our red line touch the y-axis? Okay, remember where the x and y-axis are. Our y-intercept then would be 6. So plus 6. Now let's go ahead and look at the other line that is green. And same process, we have our y-intercept here. And I'm going to find another point. Okay, let's see. I want a really good point. I think I see one right here. I also see one here. I see several really good points. There's lots of them. There's one. Lots of good points. So let's do rise and run again. Okay, rise 1, run 2. So our slope then is 1 over 2. And it's positive also because it's increasing from left to right. And where is our y-intercept? Remember, the y-intercept is where the graph touches the y-axis, which is at negative. So we have just written the system of equations in slope-intercept form. Okay, and the solution, we haven't talked what about a solution is. I would write this down. It is the intersection of the two lines, where they meet at. So it's this point right here, and I'll write the word solution next to it. So the solution is a point, therefore we would write it as an ordered pair. The x value of that point is negative 6, and the y value of that point is negative 4. So that point right there is the solution to the system. Now, it's great if our equations are written in y equals mx plus b, but perchance, what if your answer choices on a multiple choice question are not written in slope-intercept form? They might be written in standard. And we have learned how to convert these into standard. So open your notes to the inside and take a moment to try converting those two equations into standard form. Let's go ahead and write them down. Okay, the first one was y equals 5/3 x plus 6. And that one was in red, and our second one was green, and it was y equals 1/2 x minus 1. Now take a moment, pause the video, and try and convert both of those to standard form. Check your answer for the first equation. I've converted it to standard form. Let's remember what the steps are, and we'll go through the second equation together. So the steps are that we don't want fractions when it's in standard form, so we multiply the entire equation by the denominator. So in that first equation, the denominator was 3, so we multiplied the entire equation by 3. In this one, the denominator is 2, so I'm multiplying the entire equation by 2. 2 times y is 2y. 2 times 1/2 x is 1x. And 2 times -1 is -2. Now remember that you can, when you're multiplying, use your calculator, especially with fractions. I'm going to write it up here. We are going to try and have the x and the y on the same side. Remember what standard form looks like. ax plus by equals c. The x and the y should be on the same side. So we're going to minus that 1x on both sides. So now we have -1x, a positive 2y on the left, but the x's on the right cancel, leaving us with just -2. If you also recall, we cannot have a negative in the front, and the very first term cannot be negative, the a value. So in order to make it not negative, we're going to multiply the whole thing by -1. Because this does not change the number, it only changes the sign. So negative times negative is positive, 1x. -1 times 2y is -2y. And -1 times -2 is +2. Now, the only thing I would change about your answer is that you don't need to put the 1 in front of the x. You can just put x. So let's write down our actual final answer. These two equations that are boxed are the system of equations. Okay, so our system of equations then is 5x minus 3y equals -18, and x minus 2y equals +2. So here's the actual final answer. This is the system of equations. We already know the solution to the system because we saw it graphed on the front. But this is the system of equations written in standard form. Unlike up here, we also have the system of equations on the first page right here, but it is in slope-intercept form. So keep in mind you could see it either way, so we need to keep practicing converting to standard form. Okay, the last bit of this part of the lesson, day 1, is the bottom. Types of solutions that we might see. Okay, this is what we just saw. A solution, the solution, remember, means where they intersect. So this right here, these graphs that are intersecting, they intersect at one exact point. That point is the solution. So in this case, we have one solution, and that solution is located at -2, 1. One point where those two lines meet at. But what happens when lines don't meet at all? So if we look at the one next to it, those two lines never meet. And we call those, if you recall, they're called parallel lines because they never intersect each other. That should be a term you're familiar with from middle school. So if they never intersect, then that means they don't have a solution. Lines like this have no solution. Okay. Now, what about if it's the same line on top of another line? A line on top of another line. That's interesting. These are called coinciding lines, and they share all the same points. We have two lines there, but they have every single point in common, which you could probably guess where I'm heading with this. That means that this system of equations has infinite solutions because every point on one line is also on the other. So those are the three types of solutions you may encounter. Usually, almost always, we will be talking about one specific solution, one solution. But occasionally you will find ones that don't have a solution at all or have an infinite number of them, okay? So this was day one of the notes. So you will come across day two later. There'll be a second video for the day two notes, okay? So make sure that you're doing the practice with the sub, okay? And I will see y'all again on Wednesday.